Now, we can actually see what the range of masses for the main sequence stars are. So what is done here, note that HR diagram is not, again, a linear plot, because we have temperatures ranging by an order of magnitude from 3,000 to 30,000 degrees, and also luminosities ranging from 1,000 of the sun's luminosity up to a million times. So here again, we use so-called logarithmic scale, so that we can present the quantities that differ in numerical values by a large amount on the same scale, okay? So what you can do, you can actually then plot lines representing the Stefan Boltzmann's law on HR diagrams. So what you do, you pick a particular value of R, the radius of the star, right? And then you change the temperature, and then you calculate the corresponding luminosity. So this line here is obtained if you pick the radius to be 100 of the sun's radius. So you fix R to be 100 of the sun's radius, and then you put in the values of temperature in this range, and you calculate the luminosity. And the Stefan Boltzmann's law for this particular value of radius is represented by this straight line. If you use the radius to be 1/10 of the sun's radius, then you get this line. A radius equal to the sun's radius, you get this line, you see it's passing through the point representing sun. Then you take the value 10 times the sun's radius, you obtain this line here representing Stefan Boltzmann's law. 100,000, okay? So if we look at this, you see that basically here is the main sequence, right? Here's the main sequence. You see that the radii of main sequence stars fall in the range from about 0.1 sun's radius to about 10 times, okay? So by plotting the Stefan Boltzmann's law for different values of R, you can then see the range of radii for different groups of stars. So we see that the main sequence stars have a radii from about 1/10 of the sun's radius to about 10 or so. That's the interval in which they vary.